Hello friends, I'm Kushal from Indeed Inspiring and we are discussing reinforcement learning. Reinforcement learning is one of the three basic machine learning paradigms. So here you can see supervised learning, unsupervised learning and reinforcement learning are the primary learning paradigms or approaches in machine learning. Reinforcement learning is about taking a suitable action to maximize the reward in a particular situation. Think of a situation where you have to go to a destination, but you have three options in front of you. So, which one do you choose? Obviously, you will choose the one which is most likely to take you to the destination. So, that means that is giving you the most reward. This technique is employed by various softwares and machines to find the best possible behavior or path it should take in a specific situation. Reinforcement learning is a bit different from supervised learning. In supervised learning, you have a labeled data, and this labeled data gives answer keys to the model which is being trained. In contrary, reinforcement learning, there is no answer, but the agent, or you can call it as reinforcement agent, decides what to do to perform the given task. So, which means the agent is learning from its experiences. Let's discuss one example which will make it very clear. So, how reinforcement learning really works. Let's say we are training or teaching our dog a new trick. Look at the dog, he is very eager to, learn. Now the dog doesn't understand our language, so we cannot tell the instructions simply in our language and expect the dog to do it. So we emulate the situation. Okay. So we try to do something and we try to make dog respond in a desired manner. If the dog responds in desired one, then we reward him with some snacks. Now guess what will be the next time dog is supposed to do? So next time also dog will execute the same action with more energy and enthusiasm because the dog will be in the expectation of more food. That's like machine learning. So the dog is learning what to do from positive experiences. So similarly, dog will also learn from negative experiences what not to do. So here we have certain important things. Agent. The dog is the agent here. Environment. Environment could be your garden or your home with you. Action. Action is the set of possible activities or actions dog can perform, like standing up, sitting down, catching the ball. So different types of actions. Reward or penalty. Reward is whenever dog is, let's say, catching a ball and that was a desired action you had, you will serve the dog with some snacks or food. That's the reward. If it doesn't do that way, then in that case you will not talk with the dog for some time. That's a penalty. States. After taking an action, let's say dog catches up a ball. So that's a transition from one state to another. And similar way, if dog sits down, that is a transition to another state. So catching a ball, throwing a ball, sitting down, these are different states. Policy. Policy is the way dog is about to take an action. Here we have another example. So the problem here is we have an agent and there's a reward and there are multiple hurdles here. The agent is supposed to find the best possible path to reach the reward. The image explains the problem in more easy fashion. Now your task is to identify the agent, states, action, rewards, and environment and write them down in the comment section below. I'll read it through. Alright, let's talk about contributors. Here you can see Richard Ernst Bellman. He was an American applied mathematician. He introduced dynamic programming in 1953. He also made very important contributions in the field of mathematics. He formed Bellman equation. It's a necessary condition for optimality associated with dynamic programming. If you know about Bellman equation, let me know in the comment section below. because that is something which is really important in case of reinforcement learning. We have another contributor here, Andrei Markov. So he was a Russian mathematician and best known for his stochastic processes. Do you know about stochastic processes? If you want to know, please let me know. I'll create a video for it. So the primary subject of his research became Markov chains and Markov processes, and that is something is of our interest here. So his Markov decision processes, they gave a partly random and partly controlled behavior to the agent action. So this is another important part in reinforcement learning. And these actually form a concept called as Q learning. So Q learning is a model-free reinforcement learning algorithm. The objective is to learn quality of actions, telling an agent what actions to take under what circumstances. The important thing is it doesn't require a model of the environment. As we discussed, this is not supervised learning, but it can handle problems with stochastic transitions and rewards without requiring adaptations. So you can see in the diagram here, you have an agent and agent performs action. While the agent is performing an action, the environment is giving back some next state, that is st plus 1, and also giving a reward, that is it is adding up to the previous reward. Okay, and based upon this the agent will keep on learning and modifying the actions. All right then, so please like and subscribe our channel, and also write down in the comment section below which topics do you want in the next videos. Don't forget to press the bell icon. Thank you, thanks a lot.